Chapter Mechanical Properties of Fluid, and we are solving Ncert textbook questions here. This is your question number 5. In this question it is asked, a 50 kg girl wearing high shoes balances on a single heel. The heel is circular with a diameter 1 centimeter. What is the pressure exerted by the heel on the horizontal floor? So it's a easy numerical. Just you can solve it using the definition of pressure. As you know, pressure is equals to force per unit area. Now here you see, that means mass of the girl is given, that is 50 kg. Therefore, F is your what? mg, that is nothing but 50 into mg is your 9.8. So you can say 50 into 9.8. If you multiply this, it will be 5 8 are 40, 0, 4 carry over, 5 9 are 45 plus 4, 49, double zero, decimal is there, so 490 Newton. This is the force here calculated. Now see, what is your area? And it is given that the heel is circular. Heel is circular. With a diameter is given 1 centimeter. Diameter is 1 centimeter. Therefore, in meter if you convert it, before going to find out the area, so it is given diameter is 1 centimeter. That is nothing but 10 to the power negative 2 meter. Then radius is what? This will give you, radius is your 10 to the power negative 2 over 2 meter. This much is your radius. Now just put the values. We are going to put these values in this formula. Now let me write this. Then you see, as we obtained force, that is F is equals to 490, it was, so 490. And area formula is here, pi r square. As it is circular, heel is circular, that is pi r square, and r is your 10 to the power negative 2 by 2 as we calculated just now. The pi, let us take 22 by 7. R square 10 to the power negative 2, this is the value of radius, and this is your whole square. Now just calculation part is left, or you can consider pi as 22 by 7 or 3.14 as it is. Now if you simplify this, the process of simplification, let me show it here. 490 over 22 by 7 into 10 to the power negative 4 by what? 4. This is the value. Then do one thing, is 490, so let me write 49, 10 to the power 4 is here, 7 into 4, it is your 28, and this 1 0, let me give here 10 to the power 5, divided by this much, divided by is your 22, power negative 6 Newton per meter square. Just calculation part is left, and if you calculate or simplify this answer will come. I hope it's clear. Thank you. Next, your question number 6, chapter Mechanical Properties of Fluid. Torricelli's barometer used mercury. Pascal's duplicated it using French wine of density 984 kg per meter cube. Find the height of the wine column for normal atmospheric pressure. Here we are going to take density of mercury, that is rho 1, 13.6 into 10 to the power 3 kg per meter cube. Height of mercury column, it is given here. Say it is H1, that is 0.76 meter. And density of French wine, it is also given rho 2. Let us take it as rho 2, 984 kg per meter cube. We have to find out H2, that is height of your French wine. Here just we know that, or we can assume, say height of French wine is your H, and H pressure for H height of French wine exactly equal to the pressure of mercury column. For that you have to know that rho 1 G H1 is equals to rho 2 G H2. So this is the pressure of mercury column, and here it is the pressure of, sorry, this is the pressure of your French wine, and here we have taken pressure of your mercury column. So now see G in both sides equal, cancelled out. We have to find out value of H2. So H2 is equals to, it will be rho 1 into H1 divided by rho 2. And all these values are given, just we have to put the values and then we have to calculate. Now let us put the respective values of this. All these values are given here. See, if we put the values, that is H2 is equal to rho 1. Rho 1 is your 13.6 into 10 to the power 3 into, and then H1 is how much? 0.76. So here it is 0.76 divided by rho 2, density of French wine, that is your 984. Here it is 984. Now the simplification part is left. How to simplify? You see, 10 to the power 3, that is 1000 is here. To the right of decimal, how many digits? 2. Here how many? 3 digits. So simple, you can write 136 into 76 divided by 984. Then you can cancel out. After cancellation, you see, you will get, after simplification, here 68 into 19 divided by 123. If you cancel out this, then you have to multiply these two and you have to divide it by this. After that, your answer will be 10.5 and unit is your meter. So this is the required height of your French wine column. This is your answer. So it was an easy question. Now we are going to see question number 7. Here it is asked, a vertical offshore structure is built to withstand the maximum stress of 10 to the power 9 Pascal. Is the structure suitable for putting up on the top of an oil well in the ocean? That means this oil well, these are present actually under the sea. So in the top of that well, the offshore structure has to be placed, and definitely this will be under the sea. Then is it suitable or it is going to be crashed? For that, and it is also given that depth of the ocean is 3 kilometer. So taking the depth as 3 kilometer, you have to calculate the gauge pressure, that is rho GH. So here if we calculate the pressure, that will be your pressure is equals to rho GH. Now you see, here rho, that is the density of water, and you have to take this as 3 into 10 to the power 3, and G, that's your 9.8. So 9.8. Again H, that is depth of this, it is 3 kilometer. So in meter that will be 3000 meter, as it is in kilometer it's given. Now just simplification part is left. I repeat, we are calculating the pressure at a depth of 3 kilometer. The pressure at the depth of 3 kilometer, it comes as, if you simplify this, now 3 3s are 9, and if you simplify it will be 2.94 into 10 to the power 7 Pascal. So this is the pressure at that much depth. Now see, the maximum stress that offshore can take, it is 10 to the power 9 Pascal. So which is much smaller than 10 to the power 9 Pascal. So what your conclusion? So the structure can withstand. So what is the question? Is the structure suitable for putting up on the top of an well? So the structure is suitable for that purpose. That means it can be placed at that much depth. I hope it's clear. Thank you.